Section 3.8, Inverses and Radical Functions. Find the inverse of a polynomial function and restrict the domain to find the inverse of a polynomial function. We've done inverses before, so some of this should sound very familiar to you. If a point AB is on the graph of f of x, then the point BA is on the graph of the inverse of f. So remember what the inverse function does is it interchanges the domain and range. So let's do an example. Here's a point on the function f of x, 2, 8. So if 2, 8 is a point on f of x, then we know that a point on the inverse of f of x will be 8, 2. So let's take a look and remind ourselves how we make the inverse of a function. So to find the inverse of a function, let's go ahead and start from the beginning. So we've done this before. Just as a reminder, what we're going to do is the first thing is we're going to use y notation because it's easier to work with. So instead of f of x, we're going to replace that with y. So y is equal to x cubed. And then we're going to switch x and y. So we're going to form the inverse. So instead of y, we'll have x. Instead of x, we'll have y. And finally, we solve for y. So the opposite of the cubing something is to take the cube root. And so we have that the cube root of x is equal to y. So in other words, if f of x is equal to x cubed, then f inverse of x is equal to the cube root of x. And just as a reminder, one way that you can tell that a function is the inverse of the other, if we apply the function and the inverse to a number, so we apply the function and then its inverse, it should leave the value unchanged. For example, let's take, let x equal 2. What if we did f inverse of f of 2? Now remember, this is function composition, so sometimes you might want to set it up in a picture. You don't have to. But first we're going to do f, and then we're going to do f inverse. And we're going to put in the number 2. If we put the number 2 into function f, that means we're going to cube it, and we're going to get 8. And if we put the function number 8 into the cube root function, the cube root of 8 is 2. So we put in a 2 to the function and its inverse, and it leaves the value unchanged. Okay, so that's a quick recap of inverses. One thing that we haven't talked about is the relationship between a function and its inverse. So this is actually the function that I had earlier on the previous slide. So this is the graph of f of x is equal to x cubed, and this is a graph of f inverse of x, which is the cube root of x. And one thing to notice about a function and its inverse is one is a reflection of the other. So whenever you have a function and its inverse, it is a reflection over this line that I'm drawing in right here. A function and its inverse are always reflections over the line y is equal to x. So that's how the function graph and its inverse graph are related. In order to have an inverse, though, a function must be 1 to 1. So this is something that we talked about way back at the beginning of the course. So let's kind of go through this again. Okay, so a function is going to map a number onto its inverse. And let's take a look at this function here. This function has the point 2, 4, and negative 2, 4. If I was going to draw that in an arrow diagram, here's x, and here's f of x. The number 2 is mapped onto 4, and the number negative 2 is also mapped onto 4. Remember, we looked at this and we said this is still a function. Why? Because every x has exactly one y to go to. That's what makes it a function. But what if we wanted to reverse the direction and make f inverse? Now, the number 4 has a problem. Because where would it go? Should it go back to 2? Should it go back to -2? See how the number 4 now has 2 values with which it's paired? That's why we can't invert this. We can't go backwards because of this situation that 4 would have 2 places to go. And in a function every x has to have only 1 place to go. So this is a function which is not invertible. Why? Because it isn't 1-to-1. So just as a reminder, a quick way to tell if a function is not 1-to-1 is to draw a horizontal line. And if the horizontal line can cross the function in more than one place, that means the function is not 1-to-1. So does that mean this function, which you probably recognize, f of x is equal to x squared, does that mean that x squared has no inverse? Well, what we do in cases like this, where the function is not 1-to-1, is we do what we call restrict the domain. So what we're going to do is we're going to restrict the domain of x squared so that it becomes 1-to-1. So let's clean this up a little bit. And I think there's a pretty obvious place to restrict the domain to. If we only considered values of this function in this area here, if we restricted the domain to the values from 0 to infinity, and we ignored this side of the parabola, then we would definitely have a function which is 1-to-1. And so that's how we get around this problem. We restrict the domain of the function. So again, if a function is not 1-to-1, we can restrict the domain so it does become 1-to-1, creating a new function that will have an inverse. So again, what we're going to do here is we're going to restrict the domain to the interval from 0 to infinity. And then the graph would look like this. So now it's invertible. Now it's 1-to-1. So if we restrict the graph of f of x is equal to x squared, if we restrict the domain to, again, the interval from 0 to infinity, then we can make the inverse. And how would we do that? Just like before, we would go to y notation. We are going to switch x and y. And now we're going to solve for y. So the opposite of squaring is to square root. So the square root of x is equal to y. And this is not surprising that if the function is a squaring function, then its inverse is the square root function. Let's do another example. Restrict the domain of f of x is equal to x minus 4 squared, and then find its inverse. All right, so let's think about this for a second. This is the parabola, but it's been shifted, so let's kind of see if we remember how it's been shifted. We're subtracting 4 inside the parentheses, so what that does is it takes the parabola and it shifts it to the right 4 units. So this is where the new vertex is going to be, and so this would be a little bit of the parabola. And again, you can see that it's not 1-to-1. So how should we restrict the domain? Well, let's do the same thing we did before. Let's just take half of the parabola. And in this case, where would it start? It would start at 4 and go to infinity. So the first thing we're going to do is we're going to tell what the restriction is on the domain. The next thing we're going to do is we're going to actually find the equation of the inverse. So here we go. We have y is equal to x minus 4 squared. We're going to switch x and y. And now we're going to solve for y. So we'll start by taking the square root of both sides. That'll give us y minus 4 here. And we'll simply add 4 to both sides to get our final answer. So the square root of x plus 4 is equal to y. So f inverse is going to be the square root of x plus 4. One more example. Restrict the domain of f of x is equal to x minus 2 squared minus 3 and find its inverse. So the first thing we want to do is we want to graph this. So this is going to require that we remember our function transformation. So what has happened to our parabola? It's been shifted right 2 units, and then here it's been shifted down 3 units. So let's go ahead and sketch what that parabola would look like. So from 0, 0, where the vertex usually is, we're going to go right 2 and down 3. So this is the new vertex. Again, we're going to restrict the domain to half of the parabola. And so what is this number here? This number is 2. So if we restrict the domain to the interval from 2 to infinity, then the function becomes 1 to 1. Finally, let's go ahead and find the inverse. Y is equal to x minus 2 squared minus 3. We're going to switch x and y. And now we're going to solve for y. We'll start by adding 3 to both sides. The opposite of a square is a square root. So now we have the square root of x plus 3 is equal to y minus 2. And the finishing touch, add 2 to each side. So the square root of x plus 3 plus 2 is y. In other words, the inverse function. Okay, so here's one for you to try. Restrict the domain of this function and then find its inverse. So let me help you get started. Normally, the parabola has a vertex at 0, 0. So think about the shift that's gone on here, restrict the domain, and then find its inverse.